All right, boys and girls, welcome back to the drive-thru. Sponsored by the deli. Hungry? Stop by the deli. Get yourself a bologna sandwich. Why bologna sandwich? Because this problem is a bunch of bologna. So, before you go on watching, understand that I'm only putting this up here because I assigned it to you, and I told you that I would take questions, so I need to be careful from here on out assigning questions. I thought this question seemed harmless and simple, and then when I looked at the solutions manual, I got confused like you guys did. So let me set it up. It reads, a force of 60 pounds act on the pipe wrench in the figure as shown. Okay? Sounds simple enough. Part A says, find the magnitude of the moment about O. This is O here, and that's A. We're going to need that. Find the magnitude of the moment about O by evaluating the magnitude of the cross product, just like we know. Use a graphing utility to graph the result as a function of theta. So the only thing that matters in part A is they want this to be a function of theta, and that's where this question is significantly more difficult than I thought it was going to be. Okay? So all I'm really going to try to do here is explain the answer in the solutions manual so it makes a little bit more sense. So the solutions manual starts out with a little picture like this. Okay? And then it writes OA is 1.5 feet. So we've changed it to feet so that we can use these sweet foot-pounds. Okay? And then it's got this F coming down like this. That is F. And this is the angle we're talking about. Okay? So I can kind of pick what they've done. They've taken this 18-inch wrench and they've assigned it to a position on the XYZ plane. Okay? And then the question being asked is, what happens to this function as theta changes? Well, let me just explain to you the only thing you really need to understand about this. If theta was 0 degrees, then our force vector would be like pointing like this if theta was 0. Can you imagine that? And then this wrench is not going to rotate at all. You're just pressing against the handle of the wrench. Okay? If theta was 90 degrees, okay, it would look like a force like that when theta was equal to 90, right? And then that wrench is going to maximize its torque. So that's what you need to know about this problem. They're also showing you that calculus works, which is good because you already spent a whole year of your life learning it. And from there, you'll get to practice with cross products. So here goes nothing. We can let OA, okay, remember, OA is here. So we're going to let OA be 0, 0, 3/2. That's the length of OA. Okay, now, then our force vector, okay, we need it to be a 60, so it's going to be 60 times a unit vector. This force vector is some combination of y and z in our picture. So it has no change in the x direction. All right, now let's think about this. We are used to it being cosine, sine. But if we look, this is kind of, oh man, let me go back to this original. If I look at this is 30. So, like, if I divided this up into my trig, this would be 1.5 times cosine of 30. And this right here would be 1.5 times sine of 30. Well, we don't want 30. We want it in terms of theta. And remember that the sine of an angle is equal to the cosine of the complement, Okay? If you can remember that. And so based on that idea and this picture, we now switch to sine theta, cosine theta. I'm trying to explain to you guys why it is sine cosine and not cosine sine. And you're right. And that's a negative 60. Okay? Trying to help you understand where the book is coming up with their solutions manual from. So now the calculus, or the multivariable calculus, because it's not even calculus yet, I understand. We want to do the magnitude of OA cross force, and to do that we're going to take the cross product. OA is 0, 0, 3/2. This is 0, negative 60 times sine of theta, and negative 60 times cosine of theta. Okay, and so the cross product, hey, I'm just going to speed this up. Hopefully we're getting better at those. I'm not going to do it all in my head. I'm just going to tell you that it's going to be 90 sine of theta. Comma 0, comma 0. That's what you're going to get when you do the cross product of those two. And the magnitude of that is just 90 times the sine of theta. So we have succeeded in writing the torque equation as a function of angle theta. Okay, so that's part A is done. Part B says use the result to determine the magnitude of the moment when theta equals 45. So when theta is 45 degrees, you get 90 times the sine of 45, and you get 45 radical 2. So for part B, it's just a value, okay? And then part C says use the result in part A to determine the angle theta when the magnitude of the moment is at a maximum. Well, in order to find a maximum, we're going to say T is 90 sine of theta. We need to find out a maximum, so we need to know when dt d theta equals 0. Okay, that's going to give us a relative max or a relative min. And so the derivative of sine is positive cosine. Welcome back to calculus. So dt d theta is 90 times cosine of theta, and that equals 0. Let's see, when is cosine of theta equal to 0? Hopefully when theta equals 90. Yes, it is. Sorry. Theta is 90 degrees. Okay, don't freak out. I'm just doing what I told you I would do, which is help you when you need it. Okay, so what does that mean? Well, when this angle is 90, okay, well, if you think about it in the original picture, if this angle was 90, then this angle would be 0 degrees, okay, and at that point, our force would look like that, which is perpendicular to our vector, which makes sense for torque. I don't know if you've seen that little thing when I push the door, but that's what this idea is getting at. If you push the door at an orthogonal or at a perpendicular, very little force will make rotation about an axis, and that is what torque is. Worst video ever. Boom!